The purpose of this video is to introduce a new concept called logistic regression. First, we need some motivation. Why do we need logistic regression? So far, we've used linear regression to predict continuous outcomes, things like grades that have a range of values. But what about whenever we come across an outcome that's not continuous? Some examples of that might be if we want to predict or understand whether someone has a disease, if we want to predict or understand whether a team will go to the playoffs this year, if we want to predict or understand whether we might need to hire temporary staff to help deliver our packages tomorrow, or maybe if a stock price is going to change in the next second. These are all outcomes that have yes or no as possible values. They're binary. And so far, we don't know how to use those as the response variable in a model. In this class, we're only going to understand binary logistic regression, but there are lots of other possibilities. You could have variables that have 1, 2, 3 as possible outcomes, still not continuous, but more than a yes or no. The example I want you to consider is the scores data because it's so close to our hearts. In the past, we created a model predicting grades from hours studied and the binary variable whether a student got sleep the night before. And that model was interesting. It helped us learn about continuous responses and what a linear regression model is. So I want you to think about that model and consider, what if instead of predicting grades, we wanted to predict sleep? Remember, sleep is binary. It's just whether the student got a full night of sleep, 8 full hours or not. So what if I wanted to predict that using grades? So depending on your grade, it might indicate whether you got a full night's sleep or not. I don't know how good that model is going to be, but I might have an idea that from a student's performance, I could judge whether they've gotten enough sleep. So you might be thinking, okay, I want to predict sleep, but why do I need to change the model in order to do it? What if we tried to use a binary response variable in a straightforward linear regression model? Because we already understand how to use that tool, so why do we need to learn anything else? The reason is because it would violate assumptions. We require for linear regression that we have a normally distributed response. And that means that our errors will be normally distributed too. But if we have a binary variable that only takes on values of 0 or 1, then we don't have anything that's normally distributed. A normal distribution is a continuous range of values, and a binary variable just cannot look like that. It's impossible. And the normal methods that we would use to fix this problem, like bootstrapping to create a distribution, we can't do. This is not even close to normal. It doesn't have a standard distribution. It's just zeros and ones, and those characteristics are harder to predict. So the rest of this unit is all going to be about logistic regression and how to implement a new kind of model to solve this very common, very interesting type of problem.